Yesterday we covered the linear model graphing using Excel and how can we find a line of best fit when we have points that are lined up linearly, right? So today we're going to look at quadratic models. Yesterday when we did the linear model, we figured that when we did our first difference or the rate of change, it was it the same? Was it constant? Was it different? What was the rate of change? Constant. Right? And then we said that the equation is going to look like y equals mx plus b, where the degree is 1 on the x. Now we're going to look at what happens when I have a quadratic model. So the quadratic models, they represent quantities that are non-linear. Which do not have a constant rate of change. So if you recall from the grade 11 or from previous when we did the review, what would be constant when you have a table of value? What do you have to do to find out if it's quadratic? The second difference would be constant, right? So in the table of value, the second difference are equal. The graph, how would the graph look like? A parabola. It's a curve, it's a symmetrical curve. It's a parabola shape. And the equation has a degree of 2. And is written in a form, we're going to look at the standard form here. So y equals ax squared plus bx plus c, where a cannot equal to 0. Because the minute that a is equal to 0, then you're going to have a linear function. Right? If a is 0, a times whatever number, that's going to be a 0. And then you will only have bx plus c, and that makes it linear. Okay, so the a cannot equal to 0. All right, so when I'm looking at a table of value, I'm going to test to see my first difference. If my first difference is not constant, then I look at the second difference. If the second difference is constant, that means it's quadratic. And then the equation, I'm looking for a degree 2. This is easy because you've seen it before, all right? So in this case, what do I have to do? Because I have a table of value, which model represents a quadratic relation? What do you think? Yeah, so you're going to do the first difference and the second difference. It's always important, guys, eyes on me for a second. It's always important to make sure that your x values are going up by 1, right? Where it's always, so that's good. I can do first and second difference. If your x values are not going up by the same value, you can't do first and second difference. I will never give you that where they're not, the same, going up by the same value. Okay? But it's always good to check. Always good to look at. Well, yes, they're going up by 1, so that's good. To do the first difference, I have to do y2 take away y1. So 238 take away 250. That's negative 12. 202 take away 238. That's negative 36. 142 take away 202. That is negative 60. So obviously my first difference is not constant, right? So I have to look at the second difference. So negative 36 take away negative 12, that's going to give me negative 24. And negative 26 take away negative 36, is that negative 24 as well? Because my second difference is constant, I know it's quadratic. I'm going to have to do the same thing for the second table to test. First difference. So 48 take away 32, that's 16. 72 take away 48, that's 24. And 108 take away 72, that is 36. First difference is not constant, so I have to move to the second difference. And that's going to give me 8. And 36 take away 24, that's going to give me 12. Second difference is not constant. Right? You guys okay with that? Second difference is not constant, so that means this is not quadratic. Looking at the graphs, can you tell me?
E is quadratic.
Well, we're looking at the graph. C is quadratic,
Sorry.
and D is not quadratic, right? Okay, so this is quadratic because it has a parabola shape. And this is not quadratic, it's linear. And then for the equations, which one is quadratic? E is quadratic, and because degree 2. What's the second one? Linear, it's degree 1. Okay, so table of value, first, second difference. Graph, you're going to look for the parabola, and then for the equation, you're looking at your degree to figure out what type of function. Are we good with that? Easy? All right. Often formulas representing real-world situation contain 3 variables. The dependent variable and 2 independent variables. For example, in the formula for the volume of a cylinder, we have volume is equal to pi r squared h. So how many variables do you see here? 3, which are? Pi is not a variable. V, which is the volume, and the r and the h. Okay? Which one is your dependent? Which one is your dependent variable? The volume is dependent, and it depends on what? On R and H, right? So the volume is the dependent variable, and it depends on the radius and the height of the cylinder, right? Well, so the radius and the height, they're independent. Right? So the volume depends on the radius and the height of the cylinder. So to determine the relationship between the dependent variable and one of the independent, we're gonna have to set the other independent variable to some constant value. So we're gonna say, let's assume that the radius is 5. Let's see what kind of relationship do I have between the volume and the height. Let's assume the height is 10. Let's see what kind of relationship I have between the volume and the radius. So we're going to set one of your variables, one of your independent variables, to a certain constant value. And then you're going to compare the relationship between the other two. Rearrange the equation to solve for the dependent variable, which is already, in this case, it's already rearranged. Dependent 1e. And then determine if the relation is linear, quadratic, or some other nonlinear function. Okay? So here's an example before moving on to example number 2. So I have my formula here, which is v equals pi r squared h. Okay? Which one do you want to set constant? The radius or the height? The height. And give me a value for the height. The height is 5. Okay. So assume, right, that the height is 5. Right? So in this case, I'm going to replace my height, my h, with a 5. So now my formula is v equals 5 pi r squared. I have two variables, the volume and the radius, right? The volume is the dependent, and it depends on the radius. Now, can you tell me if this relation is linear, quadratic, or something else? Quadratic, because it has a degree 2, right? So I set my height, or I set one of my variables to a certain constant, and then I looked at the relation between the other two. Now, what if we chose the radius to be constant? Okay, give me a value for the radius. Assume the radius is 10. Okay, so that's going to be volume equals pi 10 squared h. So that's going to be volume equals to 100 pi h. Now looking at this relation, I have volume versus height. What kind of relation is this? Linear. Right? Linear, because it's degree 1. So you see what's happening here? Yes, I started with 3 variables, but I'm setting one of the variables to be a constant, and then I'm going to determine what kind of relationship do I have. Yeah, well, usually they do give you a number. Yes, if you are doing your own testing, if you are doing your own research, you're going to have to set one of your variables. You can't have too many variables, right? You always have to set something constant. Okay? Let's look at this question. The formula d equals to a half at squared gives the distance traveled by a car as it accelerates from a stop position where d is the distance traveled in meters, a is the acceleration in meter per second squared, and t is the time elapsed in seconds. So how many variables do I have here? 3. Distance, time, and acceleration. Which one is your dependent variable? Distance. And distance depends on what? Acceleration and time. All right. Now, I need to set one of my independent, right, to a certain constant. Investigate the relationship between distance and acceleration when t is equal to seconds. So they told you they want you to set t to be 2 seconds. Okay? So what do I do here? I plug 2 for t. So I'm going to replace t with 2. And that gives me d equals a half a times 4. How can I rearrange this? Because I don't like, there's too many numbers. 4 times a half, that's what? 2. So that's going to be d equals 2a. Yeah? It's linear, right? So the relationship between distance and acceleration is linear, right? So you're going to see that when you graph this, knowing that time is 2 seconds, you're measuring your time at 2 seconds, right? You're going to see a linear relationship between distance and acceleration, right? When you're doing your measurement, when you're doing your testing, right, you're going to stop you're going to, like when whatever they're doing here, at 2 seconds they're going to stop the time, and then they're going to do the measurement between the distance and the acceleration, okay? So we know that this is going to be a linear relation. And this is what, like, in real life, when you go to, when you do your, whatever program you're going to, okay? And then you're gonna do your research, and then you're gonna collect data, or you're gonna try to graph the data. You're gonna always have to, there's gonna be too many variables, right? But you always have to make one of your variables constant, so you know which one is affecting and how it's affecting. You can't change too many things at the same time. Yeah. Like, if you're feeling, like, let's say you have a headache every morning. You have a headache. You don't know if it's because you're sleeping late, or if it's because you're not drinking coffee, or because of this, or because of that, right? So you can't just change everything at the same time, because you don't know what makes you feel better, right? You have to change one variable at a time, right? To see, well, sleeping early helped, right? Because I started sleeping early every day for the past week, right? Same thing when it comes to research. Make sense?
I have a question about tomorrow. Do we have class?
Let's see. I don't think so. But let's see. We'll talk about that. What?
Just love seeing our faces, huh?
I do love seeing your faces, but not tomorrow.
I'm okay with that, you know.
There's no problem either, you know.
All right. So now we're going to investigate the relationship between distance and time. If the acceleration is 2 meters per second squared. So in this case, the acceleration is 2. So that's going to give me d equals, what's a half times 2? 1. So it's going to be d equals t squared, no? Yes. Because a half times 2, that's a whole. So 2 halves. I ate 2 halves of 2 halves pizza. Well, that's a full pizza, man.
It's a quadratic.
This is a quadratic relationship. Yeah. Doesn't matter if you ate it like 2 halves. I mean. Are we okay with this?
Yeah.
All right. That's sinusoidal. That's sinusoidal. Now, there's linear that goes down, just so you know. All right. So, as I said, that we are going to use Excel to graph, and then we're going to look at our points, and then we're going to see are our points showing quadratic, what is it called? Quadratic relationship, I guess. I don't know. then we're gonna have to use the quadratic or the polynomial fit, okay, instead of using the linear fit that we used yesterday, okay? So we can use what we call quadratic regression. To model data that appears to lie along a parabolic curve and produce a curve of best fit. So what we did yesterday, we produced a line of best fit, that's the LOBF4, right? But when we're talking about quadratic, we're producing a curve, that best fit. Okay? So when I ask you in the question, find a line of best fit, I mean linear, right? Or when I ask you in the question, find a curve that best fit, then you're looking at a curve, right? You're not looking at a linear. You have to be careful what you read. All right.
But this one says an arc.
Huh?
I thought this one says an arc.
Does it? Let's see. Falcon sparks from a Canada Day rocket follows an arc in the air. This table shows the height of the spark at various horizontal distance from the launching point. So I have the distance from the launching point versus the height of the spark. Use a graphing technology to determine the equation of the parabola of best fit. Okay? So they want you to find the equation of the parabola of best fit. Hello, they're telling you it's going to be quadratic. All right? So now what we have to do, we have to use our Excel, right? We're going to have to enter what goes on the X, what goes on the Y. Distance goes on the X, and then the height goes on the Y. Okay? So let's see how we're going to curve that. How we're going to curve that. How we're going to graph that. All right. We got to graph it. Yeah, we did. Yeah. Can you guys give me the points, please? 5, 10, 15,
10, 25, 30.
5, 10,
1 second.
15,
25, 30?
Yes,
Yeah.
ma'am.
Okay. How about for the Y?
43,
Uh-huh.
75, 87,
It's 97.
108,
Oh, it's 97 still, miss.
97,
Yes,
108? Okay.
100.
What's after 108?
109.
And then
Did
100?
it start? Yes.
So, eyes on the board, please. Can you guys see this? I know this is like...
This is kind of pinch.
Oh, that's because of the lamp. Is that better?
Yes, ma'am.
Okay.
A little bit.
So, same thing. You're going to highlight your points. And then you're going to go to insert. And then you're going to go to the scatter plot. Okay? Always we're going to use the scatter plot. Again, you want to add axis title and what goes on the y-axis. On the y-axis,
On the right
The
axis.
height is the y-axis.
the height in meter.
Yeah, meters.
Always
Yes, miss.
include units. Usually units go in brackets. Okay? What goes on the x-axis?
The distance in meters.
And the chart title would be the height of the
Rocket. Translucent rocket.
rocket.
That's what it says. It's a rocket.
Okay, perfect. Now, you see that this is kind of a parabolic shape, no? But even if you don't see it and the question is asking you for a parabolic, you're gonna have to do parabolic. Okay? You're gonna press on the point, any point, you're gonna right click, add trend line. When you add the trend line, you're gonna see the different formats, the different trend line options. You're gonna pick polynomial, and it says next to it order 2. Order 2, that means it's quadratic. Okay? Polynomial order 2, that means it's quadratic. Alright? And you see
Degree
how,
two, miss?
huh?
You trying to say degree 2?
Yes. And as you can see, it is actually forming a nice polynomial graph. Now, if you pick any other one, look at the linear, right? It's not fitting properly, right? If you look at the exponential, it's not fitting properly. So the polynomial is fitting very nicely. Make sure that you enter display equation on chart and display r squared. Look at the r squared. It's perfect.
Yeah.
It's 1. It can't be any better than that. Right? 1 is, that means it's fitting 100%. Right? It doesn't happen all the time.
Did you say good luck?
Yeah, because it doesn't happen.
Oh my god.
Right? And as you can see here, it gives me an equation, and it gives me a quadratic equation. All right? X squared. Yeah? So you can snip this, and then you can put it on a Word document. All right? Because that's what happens when you are doing the assignment. All right? That's what they're asking you for. Do you have any question about this? All right. So I'm going to...
Scatter plot. Scatter plot. Maybe it's, yeah, it should be around there. In the middle.
Insert scatter, miss? That's
Huh?
one. Insert scatter or something like that?
Scatter plot.
Insert scatter plot. Yep.
Insert scatter chart. That's what it says, miss, for that camera. Try this one.
All right. Now, looking at this, if I look back here at my Excel graph,
I hate you.
if you want to determine,
Oh my god. Where's the one that you opened? Yeah, because I can change your language with that.
you know who it is? That's cheating.
Oh my god.
No, it's not me.
Miss January, you see me fresh.
I don't like John anymore. John
Yeah.
not on my list.
You're on the naughty list. I'm
Look
recording
at both of them right now, man. It's stressing to my brain.
Where's her X?
What class is that?
The one that's done. The one that you-
Okay, guys,
But we have
the question is asking us to find the maximum height. Right? If you look at the question, we'll talk about this in a second, but if you look at the question, it says determine the maximum of the regression curve. So where would your maximum be?
25 distance.
The highest one is
Yes, but I don't know what the highest one is,
25.
but it looks like it's between,
What's that?
it's somewhere right here, no?
25.
It's somewhere right here maybe?
It's not.
109 means 108 and 109 close.
109 looks like it's the highest, right?
Mhm.
And then that means it's at 25 meter, right? And 109 meter in height, okay? So looking at the graph, you'll be able to solve this question, determine the maximum of the regression curve, what does it represent?
How would you
So the
answer that,
maximum
miss?
happens 25 meter from where the rocket was.
How would you answer it now? How would you write it down?
109, yeah, about 109. It's about, right? We don't know exactly what it is.
Is it a word problem? Like, I just wrote it out.
I have a feeling it's more like somewhere here instead of,
Yeah,
Yeah, I have a feeling it's more like 23 to 110, and then it's coming back down. So I'm gonna change this. Okay? So because if you look at the graph, your graph is kind of like going up and then going back down here. So I have a feeling this is my maximum, which is about, I want to say about 110.
So, even though it says 109 is the highest, it would be like 1.
Yes, because I mean, what happened is
So you're gonna be.
it's gonna go up and then it's gonna go back down, right? I know what's happening between the 20 and the 25th meter, but it looks like between the two, my graph was even higher than that from the graph. It looks like it's peaking somewhere in the middle between 20 and 25, right? Where the axis of symmetry is.
Would it always
Right.
do that with parabolas, or?
Yes, in the parabolas, you always have like high, and then you're gonna get a peak, and then you're gonna go down, right? And then usually, like, because here and here, they're gonna be almost the same, right? And then somewhere it's a little bit higher in the middle between the two. Okay? Now, if you say like 25 and 109, I'm gonna say it's okay. But then, because looking at my graph right now, I feel like it's more higher in the middle between 20 and 25.
So there's a little area means where you give the answer right or wrong.
Yeah.
It has to be an exact answer.
It doesn't have to be exact,
Thank God.
unless you're doing it, unless
It's way off, miss.
algebraically you're solving it, then it has to be exact when you're doing algebra.
Whoops. Wait.
Which can I get this?
Okay, so the firework will reach a maximum height of about 110 meter, 23 meter,
Is that curve
at a
between
horizontal
about?
distance. That's about, yeah.
About? At least I learned something new today.
What?
At least I learned something new today. Well, didn't use that, about.
That's about. Approximate.
Max height. So that's what that little curvy thing is. I was gonna ask. I mean, at like maximum at. I was gonna say okay, about approximately.
No, maximum height of about. That's just about. Like, yeah, that's about. Approximately.
Miss, can I ask a question? How do you get the this one there? Do you get the equation?
You display equation on chart and display, yeah. Are we good with that?